Hello, am I audible?
Yes, sir, you are audible.
Thank you. Wait for a few minutes and then I will start.
Okay, sir.
Hello everyone. So I am Bhaskar De and I'm going to conduct this problem solving session for the course Physics through Computational Thinking. Uh, so is my screen visible?
Yes, sir.
Yes.
Okay, so as I can see, only 2% have joined. So I'll start the session. So particularly what happens in the problem solving session is we solve few problems which are closely related to the course, but here this is the first problem solving session, so I will just basically discuss about the operations in the Mathematica, and then I will try to solve some problems, but mainly those are related to the plot, and I will start to give the to solve the physical problem in the second class. Okay. So uh, Mathematica has this Wolfram Cloud formation, and also the Mathematica desktop, which is actually given to the people who have the license, but anyway I will use the online version. So in the Mathematica, if some very basic operation are this addition, subtraction, multiplication, division, so like here you can easily find out the value uh, of a summation. Now this 7 plus 7 gives 14. Now there are some particular option they are giving, like if I ask for number of primes, then it will give 6. Why 6? Because there are primes that are less than 14 is 6. So these kind of options are given in the Mathematica. Now there is an operator n. So first I will show the division. So for division, when I divide the 9 by 4, it is giving the fraction 9 by 4, but not the numerical value. So that's why we have to use the numerical value operator. But first here I will show that the what is this denominator. It will give the denominator 9 by 4, and then now also there we can use this binary form to get the binary of this decimal number. The binary form of 9 is 10012. Okay. Now to get the numerical value of the fraction, we will use 9 by 4 and we'll get 2.25. Now if we want to have the value 9 by 4 up to some no, this one will not give. So this one is 10 by 6, the numerical value up to the 4th decimal, so it will give 1.667. Now I increase the precision with the 8, so it will give 1.667. So this is the use of the n function. Now this is n of pi is 3.14159. Now if I say n of pi up to some 50 digit, so it is showing the value of pi up to 50 digit.
Sir,
Yes.
sir, zoom screen a bit.
What?
Sir, the screen, the codes are small. It's hard to comprehend. Can you zoom it a bit?
Oh, sir, fonts are small.
Sir,
I cannot hear you properly actually. Can you write down? That will be better. Now it is okay. Can you see the font clearly?
sir, it's fine now.
Okay. Okay. So now, as I have shown that how you can get the value of pi up to 50 digit. Now let's give some other example, like exp denotes the exponential 3. So now I will just show the value of the e to the power 3 is 20.0855. Now what we can do is n exp 3 comma 10. So it is now giving the value up to 10 digit. Now there is an option that is scientific form. What does it? Scientific form is basically when we write something we get this 10 to the power form. So it is 2.008553692 into 10 to the power 1. This is the scientific form of this particular value. Now there are also other options you can give you can get from the more option. Now let's get back to the numerical value operator. So n sine of 30 is 0.5. So now I use the scientific form and it will give 5 into 10 to the power minus 1. Now n 1000 factorial. So this is the value of 1000 factorial. Now we can do a lot of things, like now there is something called engineering form. So engineering form is like here you use the basically decrease the exponents 10 to the power to up to 3 or 3 order 3 or 2 order. Also n 2 to the power uh, this is the value of 2 to the power something like 10 lakh 2 to the power 10 lakh. Okay, so now this is the numerical operator, numerical value operator. Now I'll go to the plotting function. Plot xp x 5 5. Now it is showing the uh, graph of x e to the power x. Now there are a lot of options like axis, color, image size, add fill, background, and then more lot of things. Plot x is on 5 axis level hold from x comma hold from y plot level hold from plot of y equal to x e x. Mr. Bracket. Yeah. So now I use this hold from x and hold from y to use this name of the variable as there. This is x and this is the axis is y, and then the title of the plot is plot of y equal to exponential of x. Now this add fill function do this thing that the area covered by the curve is showing in the plot. So for that is we need to use this particular thing, filling automatic. Okay. Now I will again copy this particular line. Now plot theme classic. So basically plot theme classic did this, like the font of the x-axis and y-axis and the title are turned into time symbol, so which actually looks better in some cases. Now I will show something with regard related to the filling. So when you are asked to or you wanted to fill the between two curves, so how will you do it? So basically plot sine x plus x by 2 comma sine x plus 2x. So these are the two function in between you want to have that filling kind of thing. So now x comma 0 10 1. See, here you have the filling between the two curves. Now so these two are the curves, and the in between it is filled with the light blue curve. Now like you have used the filling top, and you will get the filling of the top of the yellow curve. Now I'll show how to show that how to plot multiple curve. Sin x plus cos x sin x minus cos x tan x x minus tan. Okay, so this is how you get the plot for multiple curves. Now I have added the legends. Now I'll show a complicated thing, that is, let me write first. I will show this later. Now the function I am going to show is simplify. So simplify is basically a function that will simplify the complicated expression. So this is the equation x minus 1 into x plus 1 into x square plus 1 plus 1, that will simplify and it will give x to the power 4. Now the derivative can be done by this. So now again, for the simplifying, square root of square root of x square is giving the x. Now there is a thing that will we need to take care of, that is simplify square root of x to the power 2. This will only give the square root of x square, which I have written here, but using this condition x greater than 0 will give x. Okay, now another function, that is table will give a range of value. So here we need a value of n, and the range for n is 1 to 12. So it is giving the value 1 2 3 4 5 6 7 8 9 10 11 12. There are lots of things that you can do after the using this table function, but what table can also do is table can generate a list of plots. So plot cos in I x. Okay, 1 5. So it is giving 5 plots because I have used n1 to 5. So this is for n equal to 1, n equal to 2, n equal to 3, n equal to 4, and n equal to 5. Now let's define a variable value that will store the values of a table, something like n to the power 3.5 minus n to the power 1.3. So now n 1 10, or say something 15. So it is giving the value of this particular expression n to the power 3.5 minus n to the power 1.3. Now also from table you can generate matrix like 10 I plus j. So here I 1 comma 4, j 1 comma 4. So basically this table 10 I plus j actually denotes the ijth element. So now here the value of I is 1 to 4 and j, the value of j is 1 to 4. So using these values we get these elements 11, 12, 13, 14, 21, 22, 23, 24, and so on. Now using this percentage sign, that is actually connected to the previous line. So whenever you use this percentage, it will actually do the calculation of the previous line. So matrix form of the percentage gives us the matrix form of this particular table. Now this column, we get the table of the prime number up to 15th prime number. So basically here we get a column version of the table 2, 3, 5, 7, 11, 13, and so on. So these are the various procedure to represent the table. Now if you know the binomial expansion, you can do that also here. Column table binomial I comma j I 0 8 comma j 0 I bracket center. Now you can see that the coefficients of the binomial expansion is given. So for one, that is 1. For the second is like when we do the expansion of a plus b to the power n. Now there, if you can use the power, this one I08. So for a plus b to the power 0 you get 1. So there is no confusion, but a plus b to the power 1 you get a plus b. So the coefficient of a and b is 1 and 1, and then so on. After that, a plus b to the power 2, that is a plus b whole square, you get a plus 2ab plus b square, a square plus 2ab plus b square. So that is 1 2 1. So these are the coefficient of the variables. So this is the binomial expansion. Now I will again use this particular line. So now I will use a function that is known as list plot. List plot value. So now you can see a scatter plot of these values, particular values. Now when I use the filling automatic, it is just connecting the points to the x-axis. Now again list line plot. So it is a particularly line plot, and then again I add the fill and we get this blue shadow. Now do a interesting thing. List plot table, then sine of n comma sine of 2n. Still, now here what is happening, that we are using this particular table sine n and sine 2n. So it is basically generating the coordinate, like sine n is the x and sine 2n is the y, and then we are getting this kind of plot. Now again we can use the list plot table pdf binomial distribution t comma p k p 0.3 0.5 0.8 K0250. Filling axis lot legends 0.3, 0.5, 0.8. Here you can see this is the binomial distribution. So PDF is basically the probability density function of binomial distribution, where there are like is 50, there are two parameters of the binomial distribution, that is one is n, another is p. So okay, so here this is a little bit complicated, because if you don't understand the binomial distribution, then you cannot understand this particular plot. But anyway, this is just to show that just assume that there is some kind of distribution that is parameterized by two particular number, that is one is n, that is 50, another is p. Now the n is 50 and the p is varied from 0.3, 0.5 and 0.8, and then we are generating a table of 50 points, and then we are using this filling, and we get this kind of binomial distribution. Three binomial distribution is plotted in the same particular graph. Now another interesting kind of plot is list plot table style cos t sin 2t t by 2 by t0 to 2 pi 20 lot style point size So here basically what happens is, here again we are using this cos t and sin 2t as the coordinate x and y. Then we are changing the style of the particular points using this style and the who function. So here we are using the t by 2 pi. So whenever the t is changing, like 0 2 pi, in the stepping of pi by 20, it is this particular function is giving a different value, and that's why it is changing the color also. Now again go to the list line plot. table cos k 2 pi sin k 2 pi 21 3. Now you can see that we have collected the points, and then we get uh, this star figure. So basically these are the points, vertices you can say. So these are the different procedure to represent your data, so that whenever you are representing some kind of expression or data, that's actually looks clear and something like more engaging or interesting you can say. Now there is a function that is manipulate. So manipulate is an generates an interactive thing that actually helps you to change the value in the plot in 1 10. Okay, so manipulate is generating the interactive kind of output, so that's why it will take longer time than others. And there you get a slide bar where you can slide the value of n and get the value of n square. Any doubts about the plotting things? Like here I have not discussed anything about the physics, that I'll discuss in the next problem solving session, but here I am showing how different kind of thing problems can be plotted or you can represent the data. So any doubts?
No, sir. Am I audible, sir?
Yes, 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 you are audible.
Uh-huh.
Okay.
Will you be sharing PDF of this notes, sir? Because
No
simultaneously I was trying to write these
Okay, okay.
expressions.
Yeah, yeah,
But
actually I will share this, all of this.
okay, please, sir. Thank you.
I mean, I will upload in a Google Drive, but I think NPTEL will send you the link.
Okay, okay, sir. Thank you.
Now here you can do lot of things with this particular manipulate function. So now manipulate plot sin sin x 2 plus a x x 0 to 6 6 then a 0 to 2. Now you can see that we have used this a in the manipulate function and this x is in the plot function. So now what we can change, we can change the value of a. So now here we are changing the value of a and it is slowly changing the plot. Okay, now another thing you can do with the manipulate is you can manipulate factor x to the power n plus 1 n 10 100 1. So now here we are trying to factorize the expression x to the power n plus 1. So now the first is n equal to 10, so x to the power 10 plus 1, that is the has the factor 1 plus x square into 1 minus x square plus x to the power 4 minus x to the power 6 plus x to the power 8. Now when are increasing we are getting the value for different expression. Okay,
Sir,
yes.
I have doubt here. What is the meaning of one in the argument, last argument? 10, comma 10, comma 100, comma 1. So this why there is a 1 here?
Hmm. So basically this is the value is starting from 10 to 100 with a step of 1, I think. Yes, this is, I think this is 10 to the n equal to 10. Yes, here you can see the highest value of x will be here 1 plus x and it is 1 plus something plus x to the power 10. So when you multiply this you will get x to the power 11, right? So in this one the x, it is x to the power 10 and in here here it is x to the 11. So basically this is showing that the value of n can be varied in steps of 1, like 10, 11, 12, 13, 14, and so on up to 100.
Okay, thanks. Thanks.
For example, we can change this, and now this is for x to the power 10 plus 1, and this will be x to the power 15 plus 1. 8 plus 4 plus 2, 6, 14, x to the power 15 plus 1. So this is in steps of 5. Okay, now yeah, so now here you can see that okay, let's see first. Yeah, so here we have plotted the function sine a x plus b. uh, ax plus b, where we have called the value the parameter a as multiplier and the parameter b as the phase parameter. So now the thing is that the value of x is up to from 0 to 6, which is the basically the x-axis, and then the value of a is value of a is 1 to 4, and the value of b is up to 10. And then we have two slider, one is multiplier and another is phase parameter. So when we change the multiplier, we see that the oscillation is increasing, like the frequency is increasing, and the phase parameter is actually changing the position of this particular card, or you can say that it is a traveling wave and we are seeing in different parts of the wave. So it is actually like a wave is traveling, and this is particularly the oscillation of wave is increasing or decreasing with the multiplier. Now to see the value of a and b, we will just there, this is the value of a starting from 1 to 4, and then the phase parameter, that is like 3.17, 4.34 up to 10. This is here I am going to show the plot for a function and then use the manipulate. So 1 by x to the power 3 minus x minus a to the power. Okay, so now uh, a 0.5 to 0.1. So this is the function 1 by x to the power 3 minus x minus a square, where we are changing the value of a with this manipulate function, and here it is the, you can see this is the nature of the curve. Now in this particular I mean in the line 67, what we have used, that we have used this a and b to show the value of this parameter a and b. So here we can change the multiplier and get we can see that the value of a is changing, and so the curve is changing. Also for the same case for the phase parameter, but here we will show the value of a in a different uh, in a different style, that will be using the plot level. Plot level style a font size 16, color blue. Now here you can see that the value of a is highlighted on top of the curve, I mean the plot. A is 0.5. Now we are changing a 0.8, 0.9 and so on. Okay. Sorry. Now again we can do this thing in this particular line, where we can use this a equal to 2, here you can see that a 2 and b 0. Now b is 4.3 and a equal to 2, and then you change the value of a. So this is like this is the procedure to show the value of a and b in case of manipulate. Now you can you cannot display the value like this. Okay, after a curly bracket 2.985 comma 4.13 comma then the plot. So the better way to display the value is a 2.985, b 4.13, like this one, a 1.4, and this is the graph. And then you can add the axis name, title of the graph, and so on, everything. Basically you can decorate the graph so that you can use or present your data in front of audience. Now I will show another example of manipulate, that is with the contour plot 3D. Okay, now contour plot 3D. So for 3D contour plot we need the function of 3 variable, that is x square plus y square plus az to the power 3 equal to 1. Now I will give the range of x, y, z. X is -2 to 2, y is -2 to 2, z is -2 2. Okay, yes, none, a -2 to 2. Oh, something wrong happened. What was wrong? Actually I typed full stop instead of comma, so that was the error came. And now this is the 3D contour plot for this particular function, or you can say the surface, or anything you want. So now this is the 3D plot. So here I need to reduce the size. Okay, so now if I change the value of a, you can see the change in the 3D contour plot. Okay, this is the particular plot for the surface xyz equal to 1. Oh, okay, sorry. There is no a in this function, so it is not changing. Let's put a here and see what happens. Okay, a here. you can see that the graph is changing. Okay, now I again use this particular example, and here I will do this thing. 1 to 6. Now this is a interesting thing, that here I am not only changing a parameter of the function, I am also changing the axis size. So here if I change the axis size, you can see the axis is changing and we can see the whole curve. Okay, so anything can be changed with the help of this particular manipulate function. Now another thing you can do with the manipulate lot of f x x u 2 pi 2 pi f n sine cos tan cot. So why this is interesting, because here we are actually up till now here what I have shown you, that you can change the value of the function, I mean a parameter of the function with the manipulate, like this slider. Okay, now then I showed you that you can change the axis of the plot with this x0 to b. So now you can change the axis size. Now here you can change the function, that is here I have used the plot f of x x0 to 2 pi, and then I have used this option like f sine cos tan cot. So basically f is given with this particular tab or button. So now if I the sine button is active, so it is showing the sine curve. Now if I use the cos, it is changed to the cos curve, then tan, then cot. So it is the beauty of this manipulate function. But as well as I mean with this all of this application, enormous application, the problem with manipulate is it takes a lot of it consumes a lot of RAM to calculate these things. Like these are very simplified functions, so whenever I am changing this slider, it is not affecting that much, but still you can see that it is actually responding slow. So when you use some complicated function and manipulate a lot of parameters, so it will consume a lot of RAM, and there is a high chance that your computer gets stuck. But this is a very beautiful way to represent these functions. Now another thing you can do is that, like, you can use some name for sine. Let's say I use the s, sorry, for cos I use c, for tan I will use t, and okay, I cannot use this as p, so let's say cs, this is ct. now these names are replaced with this particular uh, character s, cs, t, ct. So s is the sine, cs is the cos, t is the tan, ct is the cot function. Okay, so now again I will show another example of manipulate where we will plot three graphs, three graphs together, but uh, okay, plot xp minus xs. Okay, so these are the expression are not that simple. Just put this. So these are the three function x square by a square, x square, and a x square. So now the b line is actually fixed here, and the green and blue are changing with respect to the value of a. So it is actually changing the three graphs together. Okay, so here you can see that it is actually taking time to load the whole graph because this is the three graphs together changing. Now I will go to the use the vector plot. Vector plot, let's keep some sorry. So this is the very basic example which you have already seen in the course. So you can see this is the field yixj, which is actually rotating. So the difference with the video and here is that in this particular version you can see the color is changing based on the magnitude, not the size of the arrow. Okay, or the thickness of this arrow can be controlled to show the magnitude of the field. That will be done with this. So here you can see the arrows towards the arrows close to the 0 points are very small, but the thickness of the arrow is large when it is going like at the point 10 or something like that. Okay, so now this is the stream plot. So stream plot -1 -x +2 plus y comma 1 plus x minus y to the power 2 comma x comma minus 3 3 comma what 11. So this is the stream plot of this particular function -1 minus x square plus y and 1 plus x minus y square. So basically without this plot legend, you get only this stream plot. Okay, now as I have said that this color of this arrow actually shows the magnitude of the field at that particular point, so we need to use this plot legend automatic. So it is giving the color bar where it is showing the magnitude. So this blue or violet color shows the range of 0 to 5 like here, and then the value at the close to the border of this box is around 50. So you can also use this particular thing here. Oh, okay. Yeah, so it is showing the value 0 to 12.5. Now there is another plot, that is x minus y y star x x minus 3 x minus 3 3 uh, comma y minus 3 3 comma this gives this kind of stream plot, and then you can add plot legend. This is giving the value. Now I will show some one similar example that was available in the video, but it is going to be a little different. Fill lines, stream plot, x r to the power 3 plus x minus 1 r 3 y r1 to the power 3 plus y by r 2 to the power 3 r1. r1 is basically square root of plus y square, then r2 is square root of x minus 1 divided 2 plus y square minus 1 2 y minus 2 2 region function x y dx and n. Oh, Just a bracket somewhere. X y r1 So this is the you can understand this is the electric field when there are two positive charges. Now the equipotential surface E load 1 plus root 2 root x minus 1 whole square plus y whole square comma x minus 1 plus 2 y minus 2 2. This is the equipotential surface of the positive charge. So basically these two are the electric field lines and equipotential. So I will just draw these two. Draw these two in the same plot, and you can see this is the equipotential surface and it is the electric field lines. As you can see in this particular region, that in far away from the charges, this equipotential surface is almost parallel here. So these are the electric field lines are perpendicular, exactly perpendicular here. So I mean electric field lines are obviously perpendicular to the surface, but what I want to show you that these lines are almost electric field lines are almost parallel to each other, because this the equipotential surface are almost parallel to parallel at far away from the charge. Now after all lot of plotting, there is another thing that is required to know for in Mathematica to to calculate some series or something, that is the series function that will give the series expansion of a particular function. So this is the series expansion of this particular function, that is minus 1 by r cube plus 2 by r, where r is from minus 2 to 2, so minus 7 by 8 minus 5 by r plus 2 by 16 minus 1 by 16 r plus 2 whole square. So this is basically a Taylor expansion with respect to minus 2 up to the second order. So due to this minus 2, this is r plus 2 whole square, and other terms, higher order terms, r plus 2 whole cube and so on, and this is the up to second order. So we are seeing that r to the power 0, r to the power 1 are r square. Now I will again go back to the plot, where I will show some complicated plots, like plot evaluate evaluate table, then Bessel J. So Bessel J is a special kind of polynomial function. If you search in the Wikipedia, you will know that its form, but here what we are using, we are using this as just show some function. So this is Bessel nx. N is the order and x is the, as usual, x. Now n comma 4 x, okay, x 0 to 10 axis. So here you can see this is the plot of the Bessel function, and also I don't think here the plot legend will work properly. Great, it worked. So this is the blue line is like 1 2 3 4, then so this is the different Bessel's function plot. So this is the Bessel function n to Bessel nx. Now the value of n is varied with the table function n to 1 2 3 4. Then this function is plotted with respect with the x-axis x 0 to 10. Now I can just increase this, and you can see this oscillation. This is the plot of Bessel function up to fourth order. Now I added few more Bessel function 1 2 3 4 5 6. Okay, so now I will show one last example of manipulate. So this is a basically also the equipotential surface of the two charges, but here what we will manipulate, we will manipulate the charge of the charge, I mean the charge, I mean the quantity of charge basically. So manipulate on plot q1 when non this will take some time to type this expression actually. Q2 by non xy minus p on q1 minus 1 minus 3 q2 1 minus minus, minus 3 comma deployed true. So this expression has a lot of things that is quite unclear till now, so I will mostly explain them in the next class, but now okay, this is what is it? This is the problem with the manipulator. Okay, so actually in this particular plot, what we have seen that we are have the control over the charge q1 and q2. So here we are decreasing the charge q1, and you can see that this is actually decreasing, and then yeah. Yeah. So now this is the q1 equal to -1 and q2 equal to +1. Now this is my -3 and q2 is 1. So basically these 2 points should be here, but why this is not coming here I don't know, because last time I ran this code this was perfectly working. But anyway, the main point is that here we have two different charges q1 and q2, and where we can manipulate the quantity of charge and see the potential surface or the field like this. These two are the -3 and this is the +3. It's something wrong with the manipulator or something. What happening I don't know. So anyway, so this is basically the potential surface for these two charges. So we can use multiple charges here, but as you can see this Wolfram cloud is actually cannot handle this much load. So this has to be done in the Mathematica desktop. So any doubts? And if you ask any doubt about these things, I will explain this particular terms in the next problem solving session. So then you can actually place these charges in the different place of this plane, and then also control the quantity of the charge. Okay, so any doubts other than this particular last line? Hello.
Yes, sir. No doubt from my side, sir.
Okay, so I have a general question for all of the everyone available here. So what kind of problems you want to actually discuss here? I mean, I will prepare the next class according to that suggestion. Okay, problems related to simple harmonic oscillator. Okay, I will try to include that in the next class. And any other thing?
Sir,
Yes.
is it possible to you to take some of the problems or something related problems with the assignment? Not same problem, related one.
Yeah. Actually, I'll do that. I in the first problem solving session, I just showed different how to plot and decorate the plots, so that in the next classes it will not be a problem if I use some random expression in the plot. So basically, like here, this is the course is physics through computational thinking. So basically, every problem you need some kind of plot. So that's why I use this first class to do that. Now, as you can see in the last plot, I tried to show you the electric potential for two different charges. So I will uh, try to solve this kind of problem, and also I will include something related to the assignments, because that's the aim of this problem solving session basically.
Yes, please, sir. Because I'm facing problem in solving the assignment because I have a big gap for the physics after my MSc, almost 17 years.
Okay,
So I registered this course and I'm finding difficulty.
okay, I'll do that.
Okay, sir. Thank you very much, sir.
Okay, and any other suggestion? Because this is the first class, so I am very open to take suggestions. So according to that, I will frame. Okay, so no more suggestion. Then I will just end the call. And anyway, happy Holi to everyone.
Same to you, sir. Thank you.
Okay, goodbye.